So I would like to invite our first speaker up tonight. He is a software engineer, software developer, Sylvain. Just going to do a quick switch of the computers to his speech. Sylvain will be speaking about artificial intelligence and Instagram YouTube.
You didn't know what Instagram was?
No.
Here we are, talking about it, things of science. Alright, gonna put my clock on. Okay, hello everyone. Thank you so much for coming. So my name is Sylvain Dorey. I'm not that much of a scientist, but I really love working with them. And sometimes they hire me to do software for them about their project, about their research. So today I want to talk about once where I did software for L'Oreal, where the data scientist there wanted to visualize and do things around skincare and makeup from Instagram pictures that they found from the big influencer account. So ถ้าพวกเขาใช้สัญญาณที่ทำให้บทตรงกันก่อนเพราะว่าที่สิบเอาภาษาเราหน่อยนึงแต่เดี๋ยวนี้คนบ้านพยายามว่าสิพวกเขาใช้สัญญาณเราคนไทยเดี๋ยว let's see and hopefully it goes well. Let's go. Should I try to do just without the microphone? Because people already complain that I speak loudly, some people that are in the room. So yeah, thank you. Alright. So I will be talking about artificial intelligence. So what is artificial intelligence? Well, actually it's a set of things in computer science, a set of methods, and I want to specifically talk about machine learning. Like the name says, it's how to make a machine learn and be able to do specific things repeatedly. And then if we go even further, I want tonight to talk about automatic classification. So there are many different branches, but I want just to have a computer able to classify things automatically. So artificial intelligence medium, certain machine learning, men vera computer hian ku viak kipukati pen samong tihet. Many kasi focus sa yanchu papen ben atalot. So now we can talk about algorithm. We go a bit further. What is algorithm? Actually, it's just a list of instructions to do. It's basically only that. It's like a cooking recipe, except that we go for a cooking recipe a little bit more complicated because it can say things like if your oven is more than 100 degrees Celsius, then put only 20 minutes. If it's less, put 30 minutes. Usually cooking recipe is a bit more straightforward, but in computer science, we can do whatever we want. So it can be as complicated as that, and actually many more complicated. So yeah, algorithm mignon, pen laikan on se kamena, se kanka sut ahan, like this sheet here. So now what are we doing here, and what do I want to show you tonight? So this is about this application, this software for the marketing department of L'Oreal. We might wonder, okay, this is not science, this is not research, but actually they have so much money that they have their own research and development people that don't really know what to do with their research. they find things and they want to explore, and maybe they want to put it in the hands of marketing department, we don't know. So those people that hire me, it's like this. They had some models, they had some ideas, they want maybe to build a software around it and see what we can do with it. I have no love for this one. So this is the final product, but I will make a demonstration later, so I continue. Okay. So สำหรับเพจตัวนี้ที่เคยได้อธิบายกับเจ้าฟ้ามีขั้นตอน3 อย่างขั้นตอนที่1ดาวน์โหลด70,000รูปภาพจาก Instagram ขั้นตอนที่2จัดประเภท automatically และขั้นตอนที่3ใส่ใน browser. I will repeat them the steps so I don't say it. Okay, so now first step was to download like as many images as possible. So if we are a human being, we go on Instagram, we go there, right click, save image, go next, etc., etc. But when we are computer, we do differently. We access automatically using application programming interface or using various languages. So those people use Python, Samlab download all the images. And then, yeah, that's the first step. Second step, the most important one is to classify the images. So now an image is a very complex object because it has many colors, many shapes, lines, row, whatever. It's quite complex. We want to make it simple. So maybe you know about an example in life that has been used before. We have the 3D to 2D from a map. So this is subton because it's 3 dimensions, and this is nine because it's only 2 dimensions. So that's the way to go from something complex to simple. We will use a method quite similar. But now I have another example. Vela ku hai kanen ku ap si nakiatem lau si hai tolek tela. So what I just say is, if I'm a teacher and I have a bunch of students that I said, can you please paint? And then I will mark grade to you. I will use my internal algorithm to give one number to each picture. So my internal algorithm is quite easy. The first one, okay, I put it 9 because I've seen it for so many years and it's quite good. And then the second one, I use my internal algorithm and it's not as good as the previous one. So maybe I put 7. And then what about this one? Okay, it's actually not as good as the first one, but better than the second one. Okay, I put 8. This is an algorithm, but you don't have really a method. It's happening inside the brain. And we want to do the same with the computer. You know what? Let's go for more than one number. Let's go for 2 numbers. So for one image, if I give it 2 numbers, I will be able to put it on an X, Y axis. And that is good because I can put my images on this big new X, Y axis. So let's go. How to do that? What is the internal algorithm that has been used? Well, it has a name. It's UMAP, Uniform Manifold Approximation and Projection for Dimension Reduction. So I don't know how it works, and if you go on Wikipedia, you can learn how it works, but it's not really that important. It's like the teacher. We don't know how he's grading. He maybe, maybe he told the student before how he would grade. But anyway, it's happening in his head. We don't really mind at the end, we just want to have the grade. And we know that if the number is big, then the grade is good. If the number is low, then the grade is not good. So what this algorithm will do, it will tell me that similar pictures will be nearby, and these similar pictures are distant. So, who the kai, the can, the kai, the kai, và who, the kai, both the can, the kai. So, for example, let's take the first image. First image, I give it to the algorithm, it's giving me 32, 125. And now, Toyang, Tisson, who have me, now she say, okay, Sitchet, so it's kind of one woman, okay, so we put it here. But it's blue, it's white, okay, so it's not really close. Image number 3. Okay, it's 2 women, so maybe it's a little bit different. So we put it right there. We put 94, 57. We don't really know how the computer showed it, but we know that there is this rule at the end. So now, I want to show you the software. Here, we can see all the images that have been put at the right location. So, you will see that it's actually images. All those images have been put on this software. Now, I told you that images that are together will be similar. So let's go somewhere. Maybe we can go have a look at this nose here. What is there? So at the end, maybe I can show you that at the end there was just pictures like this that were taken from Instagram, you know, all of them. And now they've been classified. So if we go, I can zoom, and here I see woman's hair. All of the woman's hair has been put at the same place. Now, if we go, let's say here, that's maybe the best part because it's woman on the beach. All the women on the beach have been put here. One woman only, and then the background. Now let's have a look at another location. Here, we see it's just beauty products that have been put here. So in a way, the software was able to see that if I put in the south here, I have a little bit similar shape. It's human being different than product, but it's still down in the classification. If I go a little bit up, then it's not people anymore. It can be landscape, and then it becomes whatever landscape as well. And if we go around there, we would see that all those ones are actually text. So it was able to classify like this, and the tool that we built on top of that was to be able to highlight a specific Instagram account, like Balibody. We can see that Balibody, they are all around here, even though they're a little bit there. And we can filter by numbers of comments and number of likes. Those images were images of, what was it? Skincare. Now I want to show you briefly another set of images from makeup, Instagram influencer. And here we really see two big blocks. There is a clear separation. And if we go on the right, what is it? We can see a lot of beauty products, all of them. But if we go here on the left, we have women's faces, But if we go up, it's still human being, but it becomes more just the eyes. All of this was automatically classified. We just have the eyes here, etc., etc. All right. So that was the presentation of this model. Now I can quickly talk about other experiments that they did with other models. They tried, for example, to generate fake beauty products. It didn't work too well, but still it's creating the image from thousands of other products. So that's one example. Not too successful yet, but working on it. And also generating fake names with what we call natural language processing models. So this glass avocado Samuel salt scrub has been created from all those thousands of names for all the products. And also trying to do about the description generated by computer as well. So for this, I don't think we really found usefulness yet, but let's say for the previous one, a little bit more for the marketing department to have ideas about trends and everything. So, yeah. So if you are not too interested in makeup and skincare, then you could do actually exactly the same, or some people did the same, but with art. Actually, I forgot to launch it. Is with like pieces of art from American Museum. So, alright, maybe it takes a bit of time to load, but anyway, it's the same thing, but unfortunately, no makeup, no skincare. So it's a lot less interesting, but if you like art, you can go have a look. Alright, so I arrived at the end of the talk already, and okay, I just wanted to say thank you. Here is my name if you want to discuss about things like that, about software, about AI. And you could also imagine trying to do yourself with your own pictures from your own cell phone. So you would have all your selfies here, all animals picture around there, maybe family party picture. You could do with your own. Now it's easy to go online, to try to do a little bit of Python, and to try to mix the tools together and to have interesting things like that. All right, thank you.
Really fascinating talk there. Does anyone have any questions? Any questions? Yes.
Thank you very much for a very interesting presentation. So I was just wondering about how these algorithms work. So how do they contextualize objects? For example, if they screen for pictures, you have a listing or you have a ammunition bullet, it looks more or less the same, but how does this algorithm differentiate?
Yeah, so that's a really good question. Actually, this algorithm will not really contextualize. And you're talking about things that's happening right now. It's true now. They would know, okay, this is makeup, this is not makeup. The truth is what's happening. It's more the shape is similar, the colors are similar, and this would really segregate based on that. But now there was a lot of progress made out of contextualization and object recognition, being able to label the pictures from the scene. This would be a bit different and actually a little bit like not as modern as those algorithms.
Anyone else have a question? Microphone is working.
Thank you very much. That's a very good question. I wondered actually for image selection, what did you stop at that 70,000 images?
So the truth is, it's a really good question because that's actually my part of stuff. So I'm really happy that you asked it because it's a little bit difficult to put so many images in the browser. There are some technical limitations to put the images in the browser. And one thing that is very fun to see is actually the way it's been done. So the truth is that at some point you cannot put too many in the browser. So maybe the 70,000, actually there is not 70,000 in one batch. You saw two batches, skincare and makeup, and you'll be maybe 30,000 in one, 30 in the other. But what is really nice, now I'm giving a little bit of suspense on that, but the way we did was actually to create images like this. So all the images that are being collected are then put all together in one big image. So actually it's not one. For this resolution we have